Hey guys, and welcome back to another math video. Today's math topic is going to be surface area and volume of 3D shapes. So today, instead of doing my usual key points, I'm just going to talk through all of the different shapes, or 3D shapes, which ones are most important, which ones are less important, and like what you should remember. Okay, so before we begin, a lot of these are kind of intuitive, right? They're pretty easy to kind of derive on the spot. Others are kind of harder to remember, and you will just need to memorize the formulas because you aren't at the level of math required to prove them yet. But the ones that you are supposed to memorize show up much less frequently than the ones you are supposed to memorize. Than the ones you aren't supposed to memorize. So I wouldn't worry too much about it, but it is still possible. They just show up like much less frequently or even never, but they are still possible topics. So, it would be a good idea to make sure you know all of these. Okay, so we're going to start off with the cube. The cube is the simplest solid. The volume is simply s cubed, right? Because if this is s, that's s, this is s squared. And then if this is s, then s squared times s, that is s cubed. Now, surface area, we just said that this is s squared. Oh, and sorry, volume is just the amount of space an object takes up, like how much is inside of it, I guess. And the surface area is just the area of all the different faces it has. So how much, let's say you're wrapping it with paper, how much paper you would need to wrap it. Okay, so like we said here, this is s squared and this is s. We said this is s squared. So we know that the area of one of these is s squared, and we know how many faces does a cube have? It has 6, right? So we know that it is going to be 6s squared for the surface area. Okay, now our next solid is a rectangular prism. The volume is simply length times width times height, using the same thing that we did with the cube, right? Because W times H, that's HW or WH, times L, right? That's LWH, right? And surface area, I mean, it's just 2 of each one, right? Because if this is HW, this will be WL, this will be HL, right? Etc. All of these will show up twice. So the formula is just going to be 2HW plus 2LW plus 2HL. Okay, now let's move on to the cylinder, which is less frequently tested, but it's still good to know. This one is also pretty easily derived on the spot. The volume, well, we know that the area of the base is going to be pi r squared, right? Because it's a circle. And now we know that the height is h. So to find the volume, we're going to do pi r squared h, right? For the surface area, we already said that this is pi r squared, and this will also be pi r squared, right? So you have 2 pi r squared. And then now we need to find this middle section here. Well, we know that the circumference times the height will give us this part here. So the circumference is 2 pi r times h, right? So we get 2 pi r squared plus 2 pi r h as shown there. Okay, now let's move on to a sphere, and I apologize for my bad drawing. This shows up infrequently, but this is one of those shapes you just have to memorize the formulas for, again, because you don't know how to derive these on your own yet. So the volume is going to be 4/3 pi r cubed, and the surface area is going to be 4 pi r squared. And you should remember that. There's no way with the math that you know right now for me to prove that to you. Okay. Our next shape is a cone, similarly to a sphere. I don't really know how to prove this to you without more math knowledge. So you are going to just need to memorize these. Volume is 1/3 pi r squared h. Surface area is going to be pi r squared plus pi r z. And just to clarify what z is, we can draw a triangle here, right? And then we have z, r, and h, right? That is this triangle here. And because this is a right angle, we can use the Pythagorean theorem to find any one of these 3 when given the other 2. And that's what this relationship shows here. Okay, next we have a triangular prism. This is an important one. It does get tested on, but again, this one can be derived on your own. So to find the volume, what we're going to need to do is, if this side is L, as I said here, and this is H, and this is B, right? Well, we're going to find the area of this triangle here. So it's going to be the base times height divided by 2, right? So BH over 2. That's going to be the area of this. And now we need to multiply that by L to get the volume. So BH over 2L. And that is our volume, right? Now, to find the surface area, we just need to find the surface area of each individual part, right? The area of each individual part. So this we know is B times L, so this will be BL. This we know is C times L, so this will be CL. This one back here will be A times L, so that's AL, right? So far we have BL plus AL plus CL, right? That's these three sides. Now we just have the top and bottom. Now the top we already know is BH over 2. Same with the bottom, right? So it's going to be plus BH over 2. But if we have BH over 2 plus BH over 2, that's just going to be BH. So our final thing is going to be BH plus CL plus BL plus AL. And remember, these are names I've just given to these sides, but you might see different variables. You might be given numbers. Just remember what I did here. Like, if you understand what I'm doing here, you won't get confused when the numbers change or when you're given different values or something like that. Okay, and the final one I'm going to cover is the square pyramid. Again, this one you just probably have to memorize the formulas for. It's kind of hard to derive. So the volume is just going to be, when given a square-based pyramid, the volume is just going to be H times S squared over 3. The surface area is just going to be S squared plus 2SL, and L is going to be the square root of H squared plus S squared because it is the slant height. So like similarly to what I did here, right, with the cone. And yeah, so that's all the shapes that I would think you should know. I think it might be beneficial to make flashcards or to just practice, but this is a skill you should get down. Now we're just going to cover a few quick practice problems on a few different shapes to, practice. Okay, the figure below is a triangular prism. The lateral sides are rectangles. What is the volume of the figure in cubic inches? So the volume, right? And I guess just a key tip is for most 3D shapes, if you just find the base and multiply it by the height, you find the volume. There are a few that doesn't work for, like spheres and pyramids, but most shapes that works. So if you forget the formula, do that. There's a high chance that'll work. Base times height. Okay, let's just do this. So here we're going to calculate the area of the base, right? Well, and that's going to be 2 times 4, so that's 8 inches, right? And let's just recall what our formula for the triangular prism is. So let's just look. Our volume, right, is going to be BH over 2 times L. So, we know that this right here, this is 4, right? This is 8. So our B, we can say, is 4. Our H is going to be 8. And our L, which is this part right here, will be 2. So plugging that into this formula, B times H is going to be 32 over 2, right? Times 2. And we are left with 32 inches cubed, right? Okay, next, the volume of a cube is 512 cubic centimeters. What is the length in centimeters of one edge of this cube? Well, if we recall, right, this one's easy, so I won't go back. The volume is S cubed, right? That's the volume of a cube, S being one edge. So what we can do is plug in the volume, right, which is given to us, 512 inch cubed equals S cubed. So S equals the cube root of 512. Well, let's just do our prime factorization for 512. 512 is 2 times 256. 256 is 2 times 128. 128 is 2 times 64. 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4, which is 2 times 2. So we see here that we have only powers of 2. How many powers of 2 do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 powers of 2. So this is equal to 3 square root 2 to the power of 9. And what do we see here? This and this are perfect. So our answer is going to be 8, which is A. Okay, 108. Rita used 128.5 small solid cubes to build a large solid cube. The measure of each edges of the smaller cubes measure 1 inch. What is the measure of each edge of the larger cubes in inches? Okay, so we have 125 cubes and we need to make a bigger cube out of those. So again, using our formula V equals S cubed, right? We know that the volume, well, we don't know the volume of this thing, right? But we do know that the combination of all of them is going to be 125, right? Because each of them has an individual volume of 1. If they have a side length of 1, right? Let me just demonstrate this to you. We know that this is 1, this is 1, and this is 1. So the volume of a small cube has to be 1, right? 1 inch cubed. Now, if we have 125 of those, we know the volume of the entire thing, of the big cube, has to be 125 inches cubed. So we can set that equal to S cubed, right? To find out how much one side, how many cubes need to be used for one side. And so S equals the cube root of 125, which is 5. Okay, and now our last problem, we have this big word problem over here. Raquel is cutting out pieces of cardboard to make a pyramid. She will use a square piece for the base and identical triangular pieces for the sides. The figure above shows the dimensions of the triangle for each side. What will be the total surface area in square inches of the pyramid, including the square base? Okay, so we know that this is a square pyramid, and just so you guys notice, this is like a harder shape, but the surface area is the easier of the two to figure out for this when like versus volume. So let's just draw ourselves a little diagram, so I always think it's helpful. Let's just do that. Okay, so we know this is 10, this is 10, this is 13, 13, 13, and there's like more, just like imagine that, right? So the surface area of the bottom of the base is going to be 100, right? It's 10 times 10. And now we know that the surface area of this triangle, this one face right here, right? This, well, we know this is 12. We know this is 10, right? So we know our base is 10, our height is 12. So we can find the formula of that face by doing base times height over 2. So 120 over 2 equals 60. So we know the area of this is 60 inches squared. Now, if we know that, and we know there are 4 sides, we can do 60 inches squared times 4 to get 240 inches cubed, right? Or sorry, inches squared, plus the base, right? So we have 240 inch squared plus 100 inch squared, and that is the total surface area, which is 340 inch squared. 340. So that's it for this video, guys. I hope you found it helpful. I think that for shapes and 3D shapes in general, it would be helpful to memorize. It is helpful to practice. These can be hard concepts, but usually they won't ask you for shapes that require you to memorize. So here, for example, even though it is a shape that I told you should memorize the formulas for, surface area is like kind of intuitive while volume isn't. So they won't ask you usually for like the volume of a sphere or stuff like that without giving you the formula. So yeah, I hope you found this helpful. Please make sure to like, subscribe, comment if you have any questions, or email us. and we'll see you next time.